Okay, so we know that the area of a triangle is 1/2 base times height, where height has to be perpendicular to the base. But what if we have a triangle like this? So we're given the measure of angle A, and we're given the length of AC and AB. So again, what we know is that area is 1/2 base times height. Now, so far we've looked at triangles where we could use Pythagorean theorem to find the height, or it was given to us because it was a right triangle. In this case, we don't have the ability to use either of those options. It's not like we're looking at a special right triangle, an equilateral, or isosceles, or something like that. But let's try to picture what's going on, and let's find where the height is. So let's suppose we use AB as our base, then our height, or the altitude, would be from C perpendicular to AB. It would be right there. Okay, so what we need to do is find H. Because if we use AB as our base, then I know that the area is equal to 1/2 of 7 times some H. So our job is to find this guy now. So let's look now at this smaller right triangle. Because we're given an angle and one of the sides of a triangle, and it needs to find the other side. And since this is a right triangle, what we can use is trig to find the missing side length. If I'm given the length of a side and an angle and it's a right triangle, I can always use trig to find the missing sides. So we're given angle A here, so that's the one that we would use. So if we're looking at angle A, then H here would be the opposite side, and 5 here, the length of AC, is the hypotenuse. Okay, so 7 isn't the side of that smaller purple triangle. 7 feet is the length of AB, so it's the whole side, that whole side of the bigger triangle. So since we're given the opposite side, or we're looking for the opposite side, we're given the hypotenuse. That tells us that we need to use sine to find our missing side length. So the sine of 49 degrees is equal to opposite over hypotenuse, so it's equal to h over 5. So we know how to solve this. All we have to do is make sure that our calculator is in degree mode, and we're going to multiply both sides by 5 here, and we get that h is equal to 5 times the sine of 49 degrees, which you put that in your calculator, and we get that it's about, shouldn't say equal, it's approximately 33.77 feet. Okay, so now we have everything we need and we can find the area. So area is now 1/2 times 7 times 3.77. Again, we're going to round, so it's approximately that. So times, put that in my calculator, and we get the area is approximately 13.21 square feet. So that wasn't something that we can only do for this triangle. So this actually leads us to another formula. So now we can kind of generalize, and let's look at any triangle, okay? And we'll name it triangle DEF. So for any triangle DEF now, where this side is little f, this side is little d, this side is little e. Okay, so I want to find a formula for area, basically doing it the way that we did it up here for this triangle. So let's pretend like we have side F and side E. Okay, so our base, we would choose E here. And this is without loss of generality. So I don't have to choose E, but like we're just going to start by picking one. Okay, so that's my base. Then here's my height, right? So area is equal to, again, 1/2 base times height. So we're still looking for that h because the base is e here. Now to find h, I would use the sine of d, and that's equal to h over f, because that's opposite. H is the opposite of d, and f is the hypotenuse. Multiply both sides times f. H equals f times sine of d. Then I can substitute these into my formula here. So area is 1/2 base times height, so it's 1/2. The base we're using in this case is E. Height is now F times sine of D. And again, I didn't have to choose E to be my base. I could have chosen any other side, and things would change just a little bit. So if I had chosen, let's say, D as my base, okay, then my height would be there. And I would end up with, let's see, if D was my base, then I'd be looking at angle E. So I could say area is 1/2 of D times F times the sine of angle E. And the third one would be area could be 1/2 of, let's see, we use EF, DF, so it would be E times D times the sine of angle F. Okay, so in other words, all we need to find the area using this formula is two sides, like these two, and the included angle. Just like we had here, we had the length of two sides and the included angle, meaning the angle between those two sides. So if we have that, then we can use one of these formulas to find the area of a triangle.